So this is a 2 mark match the following type of question. In this type of questions, group 1 and group 2 are given and you have to match the correct options depending upon the similar properties of in this type it is different fibers that are given and you have to, and in group 2 it is their applications based upon the specific fiber and you have to match the application of the given fibers. So it is said that match the fiber with its applications. So the option 1, group 1, it is polypropylene, Kevlar, nylon 66 and Nomex. So these are the 4 options given, and their and in group 2 their applications are used as mountaineering rope, firefighter suit, bulletproof jacket and geotextiles. So if you know that for Kevlar, so if we talk about Kevlar, so Kevlar is an aramid fiber and it is very strong and lightweight. And talking about the application, why in which applications Kevlar is used, so Kevlar is used in aerospace engineering, body armor, bulletproof vest, etc. So bulletproof vest, Kevlar is used in bulletproof vest. So option for Q, it is 3. One by one we will use. And talking about Nomex, whereas Kevlar and Nomex are aramid fibers, these are meta-aramid and para-aramid fibers kind of things. So if we talk about Nomex, Nomex is used in electrical laminates such as circuit boards, and also it is used in fireproof structures. So Nomex is used in firefighter suit. So for S it is 2. And if you talk about nylon 66, so nylon 66 is basically formed by the condensation reaction and is basically used in ropes, mountaineering ropes, because of its high strength value. So for R it is 1. And polypropylene is used in geotextiles. So you have simply matched all these things. So Pika 4, P4, P4 is in 2 options. Q3, Q3 is only in B part. So B is the correct option, and for R it is 1 and S it is 2. So this option B is the correct option. I think you must have understood by now how to match their applications. So individual fibers along with their applications are very important for gate point of view. So now coming to the next question. Now this question is of assertion and reason type. It says determine the correctness or otherwise of the following assertion and reason. One assertion and second one is reason is given, and you have to find out if the assertion and reason both are correct, and if it is the correct reason, if R is the correct reason for A or not. So reading first assertion, it is said that draw texturing of isotactic polypropylene at relatively high speed is possible despite high crystallinity of the feeder yarn. I think it is correct option. We will explain it further. And now looking at the reason isotactic polypropylene has majorly symmetric mesomeric phase. These both options are correct options. So if you have read about polypropylene and the texturing process, so polypropylene is relatively much easier to spin compared to nylon and polyester. If you happen to see any of these spinning units, such as the rate of crystallization, if you look at these three fibers from the melt polyester is slowest because of the aromatic structure. The rate of crystallization is very slow, but the rate of but if we talk about both nylon 666 and polypropylene, which is of course an isotactic polypropylene, it is a textile grade material. The rate of crystallization of isotactic polypropylene is very high. If you remember, we have said that the crystallinity also is very high for a fully drawn material polypropylene, because the chain folding takes place very easily in this case. So if you look at the stress strain behavior of polypropylene, so this residual draw ratio reduced, and then finally you can get this material as far as if you want to flat the yarn to be. So if it is said similarly in this reason that isode polypropylene has major symmetric mesomeric phase, and it is relatively easier to draw this kind of thing. So both the assertion and the reason are true in this case. I think you must have understood the concept, and for this in if you want to learn in brief, so just look at the draw texturing, what is draw texturing process, and how it is different for different types of fibers, and what are the difference between fully drawn yarn, partially drawn yarn, partially oriented yarns, and fully oriented yarns. So you will understand the difference between all these things. So for this, the assertion and reason both are true, and reason is the correct, and R is the correct reason for assertion. So option A is the correct option. Now coming to the next question. This question says that the techniques used for the determination of orientation in fibers from among us the followings are: option P, that is given as first one is birefringence measurement, second one is scanning electron microscopy, third one is XRD X-ray diffraction, fourth one is differential scanning calorimetry. So if you look at which technique is used for measuring the orientation, so you must remember what are the different types of techniques that are used for measuring different kinds of things. If you look at SEM is used for looking at the fiber morphology, fiber structure at a very small scale. So if we talk about orientation means how well oriented the fiber is. If you look at the orientation, so birefringence and XRD, birefringence measurement and X-ray diffraction is used for measurement of fiber orientation. If you talk about SEM, SEM is used for, as I have said earlier, it is used for the determination of surface morphology. And if we talk about what DSC measures, so DSC is used for the determination of heat capacity of a polymer and thermal transitions of a polymer, including glass transition temperature TG and melting point. So option P and R is true. So which P and R is true in option number B? So option B is the correct option. P and R is true. I think you have understood these techniques are also very important from gate point of view, and you must look at carefully, very carefully. And because every year now and then they ask these types of questions in one or the other format, but the idea remains the same, and these are very direct types of questions in a 2 mark question, and in these questions 1/3 is negative. So do take these very carefully and seriously. Now coming to the next question. In a modern high performance blow room line, the correct sequence of the machines is: option A, automatic bale opener, then blender, then coarse cleaner, then fine cleaner. Option B, automatic bale opener, then blender, then fine cleaner, then coarse cleaner. Option C, automatic bale opener, then coarse cleaner, then fine cleaner, then last one is blender. And option D says that automatic bale opener comes first, then coarse cleaner, then blender, then fine cleaner. So if you read about high performance modern blow room line, the process efficiency and the flexibility is very high in these high performance blow room line as compared to the conventional blow room line. It consists of coarse cleaner followed by blending, and then fine cleaning is done. So first one, what is the function of blow room? It opens all these seed coat particles, that is the cotton. When it comes, it contains many types of impurities, that is seed coat particles, because it is extracted directly. So these fiber individualization as well as the removal is done. Individualization is done in after blow room, then it is then the fiber goes into carding, where individualization of fibers is done, but in glow room all these cleaning kind of things are done. So first one is the bale is opened. So this is common for all, but if you look at when the bale is opened, then there are particles. First one, coarse particles, that is high in size. These are first clean, then they are blended. in during the blending process, these coarse particles are cleaned and then blended, so that the when the blending occurs, then fine cleaning can be done easily. So option D is the correct option in this case. Automatic bale opener, then coarse cleaner, then blender, then fine cleaner. So option D is the correct option. Now coming to the next question. This is also a 2 mark question which says that as compared to the cylinder, Doffer has low rotational speed and lower wire point density. Second one is lower rotational speed and higher wire point density, higher rotational speed and lower wire point density. Option D is higher rotational speed and higher wire point density. So a cylinder and Doffer, this is both is used in the case of carding. Though so carding machine is we are talking about carding machine. So if you know about the rotational speed sequence in carding machine, then the cylinder speed is highest, followed by liquor in, then comes the Doffer. Then comes the Doffer. So the cylinder surface speed is higher than the corresponding speed of the Doffer. This speed difference means that the web is condensed uh, on the surface of the carding machine. So what is Doffer? Basically, Doffer is a revolving cylinder or a vibrating bar with teeth in a carding machine which doffs or strips off the fiber from the cards. And if we talk about the setting between the cylinder and the Doffer is closest setting in the card. The setting mainly depends upon the cylinder speed, the hank of the delivered sliver, so on and so forth. So uh, as you can see that the cylinder has highest speeds, so the Doffer has lower rotational speed and also the lower wire point density, because since cylinder is highest, we are in this question it is talking about the Doffer. Doffer has both lower speed and lower wire point density compared to the cylinder. The cylinder has the highest speed come in the entire carding machine. So option A is the correct option in this case. Now coming to the next question. Assuming no fiber loss in draw frame, if draft is equal to doubling, then the delivered sliver as compared to the fed sliver will exhibit. Option A, decreased mass variation and higher linear density. Option B, increased mass variation and lower linear density. Option C, improved fiber orientation without change in linear density. Option D, poor fiber orientation without change in linear density. So in this case, what it is said that draft is equal to doubling. Draft, in this case it is said draft is equal to doubling. So what it means basically, how if the drafting the number of drafts given in this case is equal to the number of the doubled slivers that is used. So why this is done? If similar drafting means stretching, the fiber stretches in case of drafting, but in case of doubling, the sliver quality improves by doubling the fibers. So what actually happens, if the drafting is equal to doubling, then there will be no change in linear density, since how much the we did the drafting, the exactly on the same number we did the doubling, so no change in the linear density will take place. But what would be the use of drafting then? So drafting improves the orientation of the fiber. So no change in linear density, but the improved fiber orientation will be improved due to the drafting and the doubling that is done on the fiber surface. So option C would be the correct option, improved fiber orientation without change in linear density. So this was also the theoretical question, but you need to know the basics of draw frame and combing process. What is the role of drawing and doubling process? So the drafting is multiplied, whereas the doubling is divided, if you have solved the numerical type of questions of drafting and doubling. So I think it is very much clear to you now.